Be anti-positive.
There's no post like is this him? No. That's a dude.
I'm worried our live stream is really delayed. Oh, There's not too much buffering. I'll try to upload a video. We had a good third hour.
It was in my PD.
All right, so we'll do it live. All right, here it is. I am so glad I teach all the geometry sections because if you do switch classes, you're still going to be in my class. I have an algebra class at the end of the day, and like half of them are going to Vanderbilt, and half of Vanderbilt's going to be here. And it's like,
I tried to come here.
so sad. I'll be so sad. All the geometry kids will, because I'm the only one that teaches geometry. But it makes me so sad.
No. Unless you're with Travelers, you will not.
Well, it depends. Typically algebra 2. I think the school might have another class that you might take. I think that's the beginning of where it like forks, right? But typically, all of you, I think, should do algebra 2, personally. Well, I mean, you know, whatever. I would love to be your Mr. Feeney and follow you throughout your career. Yes.
I love Mr. Feeney. He's the greatest.
Wow, that was pretty good.
That would be fun, to teach a different class every single year and never be able to use the same material twice. Right? So, anyway. Let's do this. I would love to teach math every year with you guys. I love all of you. I really do. I'd never say it out loud, but I do. I really do. All right. That's the joke. That's the joke. That is the joke. Even though none of you dressed up with me. Frickin' Tide Pods. All right. Okay, Natalie, stop. All right. All right, so we're going to use this diagram for the following proof. So here we go. It says prove that angle 13 or angle 3 is congruent to angle 15. Now we can't just say, hey, they are, right? Even though they look like they are, and they definitely will be. There's a couple steps in between. So first off, how are we going to get 3 down to 15? Well, we need to state the given, right?
Yes.
And again, you need to do this tomorrow, not just because it's important, right? You wouldn't be able to use cap if you didn't know they were parallel. But also because it's 3 points, right? So it's on you to remember. We are given that line P is parallel to line Q. And we're also given that line M is parallel to line N. This is important. Okay? Now, given that information, I know that 3 is going to be congruent to 7 by cap, right? Because we have 2 parallel lines cut by a transversal, which means corresponding angles will be congruent. So I'm going to write that angle 3, is congruent to angle 7 by cap. We're not there yet, but we're on our way. Now, what do we know about 7 and 15? Hannah? Right, so they're going to be congruent as well because we have 2 parallels cut by a transversal, right? So 7 is congruent to 15 by cap. The magic happens when you realize, look, 7 is interchangeable with 15. So what is that property? Again, I'm using the orange here just to point that out. You don't need to write that, okay? When I switch out 15 for 7, I get angle 3 is congruent to angle 15. When I switch out stuff, I call that what? What property is that? Substitution, S-U-B-S. Don't forget the S, otherwise it's subtraction property. Okay? And now we're done because that's what they wanted, right? Swag box. The rest of the year will be like this. Which is amazing because normally when people take geometry, they absolutely hate proofs, like with everything inside of them. And I did too when I was in school, and it's because no one actually teaches them. They just say figure it out, basically. But I figured it out. And I'm very happy about that, so I love that you said that. Prove that angle 10 is supplementary to angle 7. Okay, well, here's angle 10. And angle 7 is already blue, so I'm going to keep that blue. We want to say that they're supplementary. They're not going to be congruent. necessarily, right? They'd both have to be 90 if that was the case. But they're going to be supplementary. How do we prove that? What do you think, Bailey?
Well, 9 and 10 are supplementary by linear pair.
Okay, so we're going to write that. Angle 9. Again, there's lots of ways to do this. But angle 9 is, and angle 10, not congruent, right? And angle 10. I know you can't. I know you can't. I know you can't. Listen to the words I'm saying. Angle 9 and angle 10 are supplementary. Write that. I'm trying to keep the diagram here. Okay, you can see the first line. Most of you can. Angle 9 and angle 10 are supplementary. Now, why do we know that? By linear pair theorem. Because they are a linear pair. 9 and 10 are a linear pair. Okay? Now, that's a true statement. Is that helpful? Does that get us closer to our goal of saying 10 and 7 are congruent?
Yes.
Okay, so what are we going to do with angle 9 to get it to angle 7? Yes, Bailey?
9 and 1 are
9 and 1 are congruent. And how do we know 9 and 1 are congruent?
corresponding.
Okay, so I'm going to write angle 9 is congruent to angle 1 by cap. This is true because we do have two parallels cut by a transversal, right? There they are. By cap. All right, I'm going to scroll down so you can see. But again, I hope you see the logic here more so than the writing. Okay, we can look at the writing later. So we said 9 and 10 supplementary by linear pair. 9 and 1 are the same. How are we going to connect 1 to 7? We're not there yet, but how are we going to do it, Bailey? 1 and 5 by cap are congruent by cap. And then the last step, before we, the second to last step, the penultimate step, if you will. How does 5 connect to 7? Vertical. So 5 is congruent to 7. Now, this is a lot of things to jump, right? And what I mean by that, I'll tell you in a second. 5 is congruent to 7 by vertical angles theorem, right? Scissor theorem. We're trying to get 7 and 10 together. That's going to be a lot to jump through, right? That's a lot of substitutions. So here's what we're going to need. The first time we're actually going to use this, right? Because a lot of times it was like, do I use transitive property or do I use substitution? We always use substitution because it was a simple, one switch out. But now we're switching 7 for 5 and 5 for 1, right? And 1 for 9, which means we can switch 7 for 9, right? That's a lot of work. So we're going to say transitive property. I'm touching the table. Table's touching the paper. Therefore, I'm touching the paper. 7 is touching 5. 5 is touching 1. 1 is touching 9. Therefore, 7 is touching 9. Okay? Transitive property. So I'm going to say 7 and 10 are supplementary. Okay? Angle 7 and angle 10. I'll raise that up, sorry. Are sup. And we know that by the transitive property. That's the cut out the middleman one, right? There are easier ways with less steps than what Bailey did, but that was fine. That's what she saw first, and it worked. Here's the shorter way. It doesn't require vertical angles, okay? You want to see another way to do it? Here it is. I'm trying to get 10 and 7 together, right? So I would say 10 and 11 are supplementary. 11 and 15 are the same by cap. 15 and 7 are the same by cap. Transitive property, 7 and 10 are supplementary. You dig? Okay. Swag box, because that's what the people want. And who am I to deny the people what they want? Questions on those? Cool. I am proud of all of you. I love my job. All right. Angle 7 is 85 degrees, they say, so I'm going to mark that on my diagram. That's 85. It's an 8. So 85 degrees. They tell us angle 10 is 115 degrees, which is far too high. It says find the measure of each given angle and state whether you use vertical angles theorem, linear pair, or corresponding angles to get your answer, okay? So down here, you're going to say what the angle measure is and how you got it. In order to save time, because we have a lot to get through, I'm just going to say out loud how I got it, and I'm going to write down the angle measures here, okay? So first off, 10 and 14, are they congruent? No. Why aren't they, Macy?
It's not parallel.
P and Q aren't parallel. That's going to happen to you, okay? Watch out. We don't have two parallels cut by a transversal, so 10 and 14 aren't. Again, cover up the ones you aren't looking at so you can see it more clearly, okay? What about 10 and 2? I sound like a Bartos. 10 and 2.
Yes.
They are because we have two parallels cut by a transversal, which means 10 and 2 are the same thing. I know 10 and 12 are the same by vertical. I know 2 and 4 are the same by vertical. Muchas gracias. So those are all 115. We're on page 2. Cool. Let's look at the blue angle, 7. Are 7 and 15 going to be congruent? Yes, because W and V, those lines are parallel, so we do have a parallel cut by a transversal, right? Two parallels cut by a transversal. So those are the same. I get that by cap. I know 13 and 15 are the same by vertical. I know 5 and 7 are the same by vertical, right? Scissor theorem. So those are all 85. Now, I don't know anything about the other angles. So how am I going to figure that out? How would I figure out what angle 1 is, Nellie? Yeah, and we know we can do that because we know that those two angles, angle 1 and angle 2, the measures of them, add up to 180 by linear pair theorem, right? They're both supplementary. Remember that proof we did a couple quizzes ago, right? Today's a good day. So, how much is left over for angle 1? Well, 180 minus 115, let's do it in our heads. What's 180 minus 100? What's 180 minus 100? 80. What's 180 minus 10? I'm sorry, 80 minus 10? 70. 70 minus 5? 65. Words are hard, math is easy. I'll try that again. 180 minus 100 is 80. Minus 10 is 70. Minus 5 is 65. That's how you should think about it in your head. I think it's more efficient. If you try to carry ones and stuff, you're going to get lost, okay? Place value. So important. We get 1 and 3 by vertical. 9 and 1. Are they going to be congruent?
Yes.
Yes, and you can tell because like 9 is also going to be 65 by linear pair theorem. Also, we have two parallels cut by transversal. Right. Are 9 and 11 congruent? Too soon? Yes. Vertical, right? What about 11 and 14? Are they going to be congruent? No way, right? 11 and 15, definitely not, right? But 14 and 16 are going to be congruent. Same thing with 6 and 8. How do I know what those measures are? 180 minus 85. What's 180 minus 80? Hundo minus 5 more? 95. I feel like 180 minus 85 is a difficult question for a lot of people to do in their head. But if you do 80 first and then 5 later, it's easy, right? What were we doing in elementary school to you guys? Making you memorize times tables. Useless! Shut up, Hannah. I'm sorry, Hannah. I love this class so much. Find the measure of each angle. Okay, so before we even begin, I'm just going to mark all the congruent angles. We're on page 3. So, first off, will the corresponding angles be congruent here? Yes, they will, because we have two parallels, P and Q, cut by a transversal M. So 1 and 9 are congruent by cap. Same thing with 3 and 11. Good band. Okay? That means 2 and 10 are going to be congruent, so are 12 and 4. Okay. Now the question is, does that apply down here as well? Will 1 be congruent to 5? Yes, because we have two parallels, M and N, cut by a transversal P. So 1 and 5 are congruent, 5 and 7 are congruent by vertical. Will that apply here, right? 9 and 13? Yes. Again, when we have two sets of parallels intersecting, it works out really nicely, doesn't it? Everybody's there. Enough. What does that tell us about the relationship between 3y plus 10 and 8y minus 50? What's their relationship? They're equally the same. So write that, you dinguses. A lot of you tell me that, but then like, but what do I do? Write what you said. They're equal. Bless you. Now, this is a true statement. They are equal. Will it be helpful?
Yes.
Just because I'm asking doesn't mean it won't be. It will. Why do we know this is going to be helpful? Because there's one variable, y, in one equation, right? So we're going to be able to get a number for y. So I'm going to subtract 3y and add 50. I'm going to do it all at once, one fell swoop. So that makes that 60. That makes that 5y. Don't forget your variables, right? Remember when I say don't forget your x and stalk them on Instagram, right? But this is y, so it didn't work. I divide by 5 to everything, because that's division is divorce, right? Y is going to be 12. Awesome. Now, it doesn't say solve for y. The directions say find the measure of each angle. So we need to go back and plug this in and figure out what the measures are. Y is 12. I'm going to plug it into this one, even though it's going to get us the same answer, because this one's easier to plug into. What's 3 times 12? 36. Now add 10. 46. So all the pink angles are 46. What does that make all the green angles? Whatever 180 minus 46 is, right? Let's do that in our heads. What's 180 minus 40? 140. Now subtract 6. 134. Are you smelling what I'm stepping in?
Yeah.
October 31st, 2019. 4th hour. They're getting it. Took less than a semester. New record. Normally it takes an entire semester for you guys to get used to me and all this crap. Very impressive. All right. Solve for each variable. Number 12. So, I have two parallels cut by a transversal, so let's just mark all the angles that are congruent to start out. So I know that this angle right here is going to be congruent to that angle by cap, right? And then these guys by vertical. So what does that tell us about 9x plus 12 and 4y minus 10? They equal. Now, true statement. They are equal. Will it be helpful, though? No, because we have two different variables, right? So while that's true, it's not going to get us anywhere. What we really want to know is what's the relationship between 9x plus 12 and 3x? Because then we'll have an equation with one variable, right? So 3x, all those angles are congruent, right? So if I write 3x here, I think you'll see it better. Right? They are the same thing, so you can call them the same thing, right? What's the relationship between 9x plus 12 and 3x? Hannah? They're supplementary. They aren't congruent, right? They don't equal each other necessarily. They could, right? They could both be 90, right? I appreciate that. 9x plus 12 plus 3x is going to get us 180. Just for posterity, they had done this 3 weeks ago, and they're knocking it out of the park because they actually know their crap. That's knowledge. That's learning. That's how you know they got it. 9x and 3x together is 12x. If we subtract 12 from both sides, we're left with 12x equals 180 minus 12. Let's do it in our heads. 180 minus 10, 170. Subtract 2 more. Now we divide by 12. Well, I know 12 times 12 is 144, so it's going to be bigger than that. It's going to be 14. Chance, did you say 14? Hell yeah. X is 14. It says solve for each variable, so x is 14, great. We don't have to plug it back in, but it might be helpful. Because before we said 4y minus 10 and 3x are going to add to 180, right? Well, if only we had a way to get rid of x so we could have one variable. Well, we do. We know what x is now, right? So substitute 14. 3 times 14. Do it in our heads. What's 3 times 10?
30.
What's 3 times 4?
12.
Put them together. Life, the universe, and everything. Any Douglas Adams fans in here? Hitchhiker's Guide to the Galaxy? No? Great book. The first time I read it, I missed half the book because the one I checked out from the library was missing a section about this big, and I never noticed. Wrote a book report in sophomore year of high school on it. Thought it was a bizarre book. Didn't make any sense. Read it later as an adult. It's like, haha, now I get it. Also my teacher, idiot. Shout out to you. 42 plus 4y minus 10 is going to get us what? What should they add up to? 180, right? Because they're supplementary by linear pair theorem. 42 minus 10 is 32. If I subtract that from 180, what's 180 minus 32? 180 minus 30 is 150. Subtract 2 more. 148. 148 divided by 4. What's 8 divided by 4? 2. What's 40 divided by 4? 10, so we're up to 12, right? What's 100 divided by 4? 25. 25 and 12 makes 37. It's a great day. It's a great day. Yes?
I have a question for 11. Do we have to show, like, how every angle is?
No. Great question, though. But you could, couldn't you? You could. 13. All right. Here's where things get weird, right? Yeah, it's a trapezoid, but again, we're trying to look for transversals, right? So extend your parallels and extend that transversal. And which transversal? Because there's a couple. I'm going to extend the middle one. I know. It's going to be okay. If I extend that middle one, maroon, chartreuse, burgundy, mauve, magenta. Definitely not magenta, but I appreciate the fuchsia. I'm pretty sure it's not this. Blue's Clues, right? Okay. All right. This angle right here is going to be congruent to this one right here by vertical, right? We also know that this angle right here and this angle right here are going to be capped, right? Corresponding. You see it now? I'll pause. Do you see that those two angles right there are cap, right? If you extend it out, it's easier to see. And this angle right here is the same as that because of vertical, right? So what do we know about the relationship between 3x and 5x minus 20? Not supplementary. They're the same, right? See how they're the same color? It's okay. You know what you're talking about. You just, words are hard. Math is easy. So we know 5x minus 20 is going to equal 3x. True statement? Yes. Is it going to be helpful? Yes, it will. We have one variable for one equation. I'm subtracting 3x and adding 20 at the same time. So I get 2x on this side, 20 on that side. I divide by 2, and I get x equals 10. What do you see? What is that? A triangle. Why is it called the triangle? 3 angles. Very good. And the 3 angles always add up to 180. So we know that 2y plus 4y plus 5x minus 20 is 180, right? Not helpful because we have 2 variables. However, we just figured out what x is, right? So we can plug that in. What's 10 times 5? 50 minus 20? 30. And of course it is because this is 30 up here and they're congruent, right? Duh. So now we got 2y plus 4y plus 30 equals 180, and that's going to be a useful statement, right? True and useful. 2y plus 4y plus 30, which we got from earlier, is going to equal 180. You dig? All right, I'm going to subtract 30 and put my y's together at the same time, so we get 6y equals 150. 6 is the same thing as 3 times 2. So when I think about how many times 6 goes into 150, I ask myself, how many times does 3 go into 150? 150 divided by 3 is 50. If I divide it by 3, if I divide 50 by 2, that's the same thing as dividing by 6. See what I'm saying? I divided it by 3, then divided it by 2. So I divide it by 3, I get 50. I divide it by 2, I get 25. I don't think I've shown you guys how to do that in your head yet, so if that feels really weird to you, that's okay. Divide by 2, then divide by 3, or divide by 3, then divide by 2, either way. Right? So y is 25, x is 10, and they wanted to solve for each variable, so we're good. We're done. Next one, 14. Remember this? We're going to draw what's called an auxiliary line, and we're going to make it parallel to the other two, and it's going to cut angle x into 2 pieces. And if you draw it carefully, unlike me, it'll look better. A piece that I'm going to color blue and a piece that I'm going to color red. notice we now have two parallels cut by a transversal, don't we? Do you see it? That means these angles are the same, aren't they? By cap. What's the measure of the blue angle up here? 62 by vertical, right? So that means this blue bit of x is 62. Remember, the blue plus the red is going to get us all of x, right? So we're just breaking up x into two different pieces. Not half, right? Because otherwise it'd be like, oh, that's 62 as well, right? It's not half. We just broke it up into two pieces. Now, the bottom part's a little bit more difficult. But if you extend this guy out, right, we have two parallels, and that's our transversal. Let's extend our transversal. You dig? There's our transversal. Okay, we know that this angle right here is 144 and that whole thing's 144. Well, we know that this angle here and here are going to be the same. Why do we know that? Vertical, right? So if this is 144, what does this angle have to be? Do 180 minus 144 in your head. 36. Because you subtract 140 first, and then subtract 4. So that means this bit of x is 36. Are you small when I'm stepping in? I'm going to move this away now. So now we know altogether x is going to be 36 and 62 added together. 60 and 30 added together is 90. 2 and 6 together is 8. So 98 degrees, like the boy band from the 90s. And to Mulan, right? Ready? All right. Here we go. This is the stuff we've been doing recently. I think it's going to fly by. Are you ready? How are we doing on time? 11, 15, third hour, 10. Wait, what? Oh, your fourth hour. Okay, we're good. Okay, we got plenty of time. All right. Ready? We're on page 5. There's how many pages in this packet?
11.
That's right. We're not even halfway there. But guess what? It's going to work. Watch. Here we go. What is slope? Somebody tell me what slope is. Rise over the run. Very good. Now, what does it mean to rise? To change vertically, yeah? Yes, you may. So delta y, delta x, right? The change in y, change in x. And when we say go up, we mean vertical distance, right? That's what the rise is. What is distance? Subtraction. Which variable deals with the vertical? I ask the questions. Well, the run is the change in x, so it's going to be horizontal distance. Distance is subtraction, x is horizontal. All you need to explain is this one. Why is this x2 minus x1? Because it's horizontal distance, right? It's a C. Which means the top part represents what? We already talked about it. Vertical distance. I am going to cry. That's it. If you know what it means, all the rest follows. You see what I'm saying? It's like that one pebble in the dam. If you pull that out, the rest comes out, right? We know it's rise over run. What does that mean? Well, change in y, change of x. What does that mean? Well, it's vertical distance, right? I don't know. Don't memorize. Know your crap. Turn the page. We're only going to do one of these. I give you lots of examples because everybody loves examples, right? But basically, we're just trying to figure out what is the slope between these two lines, right? We have line 1 and line 2. How do we find the slope between 2 points? How do we find the slope? We just did it on the last page. Yeah. Yeah, right? The change vertically over the change horizontally. So how much did I change going from -2 to -1? Starting at -2, going to -1, how much did I change? Well, what did I do to get there? I added 1. Thank you. Think. Now, horizontal change is going to be the change in the x, right? Delta x. How much did I change going from 0 to -2? -2. So I went left 2. So our slope for the first guy is going to be -1 over 2, or 1 over -2, or you could write it as minus sign on the outside, right? All the same dumb crap. I'm trying, Macy.
Sorry.
It's okay. All the same dumb crap. Now, we want to know whether these two lines are parallel, perpendicular, or askew. Askew just means they hit at some random angle. Think about it. If they're parallel, they never intersect. If they're perpendicular, they hit at 90 degrees. If they're neither, well, then they're not parallel, so they're going to intersect at some point, right? But it's going to be some weird angle. That's what askew means. So if it's neither parallel or perpendicular, then we must be askew. Parallel means the lines have equal slopes, right? If it's perpendicular, it means we have a flip and negate relationship, right? And if it's askew, it's just neither of those, right? So let's go find L2's slope. Same dumb crap. What's my vertical change if I start on -3 and go to -4? I went down 1, right? So -1 over -1 going to -3. What did I do? Right, well, left 2, but yeah, we went -2, right? You smell what I'm stepping in? Now that is the same thing as 1 over 2, right? Same dumb crap. Compare these. Are they the same? No, they're close, but not quite. They're not parallel. Are they perpendicular? Trick question. You might think, oh, look, they're opposites, right? One's minus, one's plus. But they also have to be flips, right? So they're neither. Calvin.
Can you show the perpendicular and askew things on the top?
Yes. So these are askew. I ask you. Think you could do those?
Yes.
Again, you could use the formula, right? Plug stuff in. Whenever you plug it in, wrap it in parentheses because you're going to have double negatives, right? y2 minus y1. Don't miss the double negatives. That's why I skip that and just do it in my head, right? It's change. Change is subtraction. Right? Difference is subtraction. All right, let's go. We got not a lot of time left. I'm turning the page. Write the slope-intercept form of the equation of the line described. What's slope-intercept form? That's right. It's the one with the slope and the y-intercept, right? So then we're going to graph it. So it says I want the line that's parallel to this guy and goes through that point. If the lines are parallel, they're going to have what? Same slope. So a parallel line to this guy is going to have the same slope. So 3/4 x, right? Because that's the slope of that guy. He's in slope-intercept form. There's the slope. And I want it to go through -4, 6. This is the homework. So I want to figure out what b has to be so that when I plug in -4 for x, I get 6 for y, right? That's what it means to be a point on a line, right? That point is a solution to the equation of the line. So when I plug in -4, I should get 6. What does b have to be to make that happen? Well, we can solve for that algebraically, right? 6 should equal 3/4 times -4 plus whatever b is, right? And the question is, what does b have to be to make that happen? Do you see where I got those numbers and why I plugged them in where I did? Wonderful. Whenever you plug them in, wrap in parentheses, right? Multiplication of fractions. We have an option. We can times by the top or divide by the bottom. Doesn't matter what you do first. You just got to do both of them. Do you want to times by the top or divide by the bottom first? Which one do you want to do? Times by the top. What's 3 times -4? Now divide by 4. -3. So we have -3 plus b equals 6, which means 9 equals b. Could you have divided by the bottom first? Sure. -4 divided by 4 is -1 times 3, -3. Same dumb crap. Okay? So b turns out to be 9, which means our equation is going to be y equals 3/4 x plus 9. Now we're supposed to graph it. Y-intercept form, right? Slope-intercept. So that's our y-intercept at 9. That's our first point. 1, 2, 3, 4, 5, 6, 7, 8, 9 on the y-axis because it's the y-intercept. And then we can use our slope to find the next point, right? And that's our line. So I'm going to go up 3 over 4. 1, 2, 3, 4. Could I have also gone down 3, left 4? Oh, yeah. Yes, I could have, right? Maybe I wouldn't have had room to go up 3 over 4. So go down 3, back 4, right? Be creative. Know what it means. Think about what you're doing. There's our line. And it will be parallel to that if you graph it. Does it go through the point negative 4, 6? Yes, it does. We did it. There's negative 4, 6 right there. Questions on that? All right, we got to go, guys. 23. Parallel to x equals 5. What does it mean to be x equals 5? That's a line where all the points have x equals 5. So here's where x equals 5. 1, 2, 3, 4, 5. That's 5, 0, right? Well, here's 5, 1. Here's 5, 2. All the points where x equals 5 produces what kind of a line? Vertical. So if we want a line that's parallel to that, that line also has to be vertical, doesn't it? So the equation for this is x equals 5. Again, think about what this means. We want this line to go through negative 7, 6. Negative 7, 6 is here. 2, 4, 6, 7 to the left and up 6. 2, 4, 6. So it's got to go through that point and be vertical. Here we go. There it is. The question is, what is the equation of that line? What do all those points have in common? All of those points on this line, check it. We've got negative 7, 0, negative 7, 1, negative 7, 2. All the x's are negative 7. So the equation for this guy is x equals minus 7. Done. If you only tried to do the y equals mx plus b thing and you're like, follow the steps, do the formula, you wouldn't be able to figure it out, which is why calc students don't know how to do this, because they don't know what it means. But you do know what it means and know how to think. This is super easy if you know what you're doing. If you don't know what you're doing, you're screwed, right? Here's the thing. It's going to be on there because I want to give you easy points. And I want you to know what it means. So don't screw up on the changeup, okay? I'm giving you an easy pitch. Knock it out of the park. Do we see what's going on here? It has to go through that point. It has to be vertical, right? All the points on here have x, negative 7 for their x, right? So the equation is x equals negative 7. It's all the places where x is negative 7. Doesn't matter what y is. Better? Okay. We're going to have some more practice with that. Turn the page. Look at 24. 24. It says parallel to y equals negative 2. Here's where y equals negative 2. Here's all the other points where y is negative 2, right? Something comma negative 2. Something comma negative 2. So it's going to be a horizontal line. If we want it parallel, our line is also going to be horizontal, right? It has to go through negative 1, negative 8. That's here. So ta-da! There it is. I would encourage you to stop writing. We're running out of time, guys. Just watch up here, take a picture at the end if you need to, or watch the video. So what is the equation of that line? Well, that's y equals negative 2 up here. This is where y equals negative 8. You smelling what I'm stepping in? Perpendicular. Flip and negate the slope, right? Last thing. Turn the page to this. Remember this from the homework? Find the slope of the line they gave you. Pick 2 points. We went up 3 over 3. That's both positive. What's the slope here? 1. So if I want perpendicular, our perpendicular slope is going to be negative 1, right? Flip it and negate it. Which means our equation is going to be whatever the y-intercept is from this dot. I go down 1 over 1. And look, my y-intercept is where? Minus 4. So the equation is going to be negative x minus 4. That's the parallel equation. There it is. Or perpendicular, I should say. I know I did that quickly. You smell what I'm stepping in. That's the magic. If you didn't get a nice look at this, right, you could do this algebraically and say, look, I know it's supposed to look like this, and it's got to go through that point. Couldn't you plug in that point here and do what we did on the last page? Focus, focus, focus. I know it has to be negative 1 for the slope. My question is, what's the y-intercept? I could do it visually, but maybe it's a gross number, right? Couldn't you plug in that point here, like we did, and find out what b is? Do that if you're not sure. Are you smelling what I'm stepping in when I'm saying that? I'm going to say it one more time. We know the slope has to be negative 1. I'm looking for what b is. I could do it visually, right? Down 1 over 1, down 1 over 1. Oh, look, it's negative 4. But what if it's a weird number, right? Couldn't we plug that point in and solve for b? Yes. So when in doubt, do that. How you feel? Better than you thought you would? I would encourage you to watch the video. Watch third hours. We did it a little bit slower. Get another take, okay? You'll be able to see some of the airplanes as well. You're going to be okay. Knock this out of the park. I'm not going to have a bunch of examples. I might have 2 of these, right? Okay? But make sure you know your crap. You going to be all right?
Of course.
Of course. Come see me tomorrow morning if you want more review. Okay? See me before school. The snow's going to be awful, and I'm going to try to get here as quickly as I can and as early as I can to make sure you guys have that opportunity. If I don't, please forgive me, but I will try.
Leonard has an airplane.
5:30 in the morning?
Swimming.
Gotcha. Woo, swimming. You're a swimmer?
My mom's the coach.
I like the swim team too.
16 days left.
Yep. Yeah, I hear tell.
You love it.
I hate
Swimming hates you.
swimming. Does it?
Good.
My mom does.
1, 2, 3, 4, 5, 6.
And the bell doesn't even ring on time. 30. 30 on the dot.
I don't know how you can.
According to schedule.
You kidding?
Are you guys going to trick or treat in the pool?
Probably not.
Do you guys wash your candy before you hand it out to trick or treaters? I always wash my candy. Got to get all the GMOs off it, right? No. I like you guys.
Oh my god.
Are you going to be okay?
I'm gonna be fine.
Yeah.
I'm gonna be fine too.
Study
I am fine.
together. Go trick or treating and study on the way, right?
Wonderful.
Trick or treating's not tonight.
Oh, that's right. I'm sorry. Don't be
Yes.
breaking the law, okay?
I'm kidding. Update. Natalie's hair. Still black.
It's not black.
It's brown.
It's definitely brown.
I'm kidding. What? I don't want it to go back to
I wish I had red hair.
Did Cheyenne help you dye your hair?
My hair used to be your
Every time I go to her house, we dye my hair.
That's
I
dope.
wish I had like ginger hair.
I
No,
used
you
to be
don't.
hair or whatever.
I think it's the prettiest hair no one
I think so too. Well,
Along with that, you get pale skin and freckles, and I get some.
but here's the thing. I'm Scottish, and I already have that. I just don't have the freckles, right? But like, if I'm gonna have that, might as well get the cool orange hair, right? My dad has orange hair.
My hair. I'm Irish, and I think I'm Scottish.
I used to have orange hair.
Like a nice
I used to too.
I used to have like bright blonde, and then it transitioned all the way through the spectrum to
People try to
this.
tell me I have red hair. I'm like, I don't see
It's
red.
very like ginger blonde, strawberry
Yeah.
blonde.
My dad just started to grow his beard for the first time, like ever in his whole life. He's always just had like the mustache,
Oh.
super weird, right? And he's like jacked, this huge guy.
My dad
The
has
beard
a-
looks amazing. There's hope for me,
My
right?
dad is a short
Patchy
blonde.
beard, right? But anyway, I'm getting rid of this, so say goodbye to that. It's going away tonight.
Why?
No Shave November, we're starting it off fresh.
Can I have
So-
another one of these?
Oh
Can I just
my
like, take any one of them?
So you're gonna have no face.
I am not letting my boyfriend participate in that.
Is your mic on?
Oh no. No. What?
The bell.
What is
I don't
this?
wanna be a
I
clown.
rushed through this.
It's 11:32. How
We don't get
expensive
until
is your
40.
mic?
Oh.
I think it's $100 new. Like that. It's not that great, but it is. But it is easy to hook up to a computer. Just USB.
I'm gonna do an ASMR.
Do it. Collaboration.
And you know what's happening?
Please. Yeah. See me number. Oh, like live. Okay. Do it live.
And you know what that means?
Mom. Molly, you look beautiful. You dressed as me today too. Very good.
That is impressive.
Yes, you got down there? Okay, good, good. What else? I knew you're my favorite today.
Wow, there's lots of paper airplanes in here.
There's a lot of paper airplanes in here. Yeah, that's right. I don't like to talk about the war, so don't bring it up. Okay?
I one?
Dark times, lost a lot of friends. Good men.
This one doesn't look very,
You know, some of them really suck.
Already have That was almost impaled me. What about this one?
Oh, you did Kermit?
Ooh, that was a good one. Did you see that? Maybe I can
Oh, okay. I was concerned with all this, and that's how you thought it's not my concern.
That was actually kind of
Yeah, that's what I just thought. You guys
go.
I want to keep this one.
Oh my gosh, I'm so sorry, dude.
Run, go, go, go.
I'm so sorry, dude. Give me back if you want.
Hello,
Okay.
What the?
What the? I'm keeping this
Yeah, I
one.
saw that. I see it. I saw it.
Terrifying. Absolutely terrifying. Alright.
Right there.
What up?
I was gonna wear mine.
What's up, Carpenter?
Oh,
Oh, yeah.
Oh, I have one.
I didn't wear it.
Hey, where did Jewel at?
Excuse me? Whoa, he just excused you. Excuse me?
This is the
Kayla! Where the jewels at?
All right, nerds, it's time to review for your quiz tomorrow.